All right, in this section, we're going to talk about dilations. So section 7.6 is a dilation. Now our first definition is what actually is a dilation. A dilation is a transformation that changes a figure's size, but not its shape. So if you take a look at our first example, it says, which of the following appears to be a dilation? If you can see, these look like the same shape, but this one is significantly bigger, so we would say, yes, this is a dilation. In B, also appears to be a dilation. They look like they're the same shape, but different size. But in C, we are going from a square to a rectangle. So because they're different shapes, we're going to say that is not a dilation. The way you get a dilation is what you do is you take the scale factor and actually kind of multiply it by the dimensions to get the new either coordinates or new lengths of whatever you're trying to find. So if you have an ordered pair and you are trying to find a new ordered pair under a dilation, what you do is you take the scale factor and you actually just multiply it by the coordinates. So 3 times 5 is 15, 8 times 5 is 40. So our new coordinates there would be 15, 40. If you take a look here, what is the ordered pair of the image of -6, -3 under a dilation of -1/3? It's done the same way. So we take -1/3 times -6 and we get 2. If you take -1/3 times -3, you get 1. Another explanation for dilation is a transformation in which the lines connecting every point P with its image P prime all intersect at a point C called the... So what we're going to do is we're going to take, and it's a transformation which lines connecting every point P with its image P prime all intersect at point C called its center. A dilation that gets bigger, which means its scale factor is greater than 1, is called a expansion. And a dilation that gets smaller or has a scale factor less than 1 is called a contraction. Now you have to kind of be tricky here because the scale factor has to be greater than 1, but it could also be, if you're talking about negatives, it would have to be greater than 1 or less than -1 if you're talking about negative numbers. The negative actually does something different with it. It makes it flip or reflect, but the 1 is actually what changes the size. So a contraction, the easiest way to remember a contraction, it's actually all those numbers between 0 and 1. Okay, the first thing we're going to do is we're going to take a look at a figure under the given dilation. If our scale factor is S3, that means that our new figure should be 3 times the size of our other figure. So what I'm going to do is I'm first going to draw a line from P to one point on my triangle. What I'm then going to do is I'm going to measure from P to that point. It looks like it is about 2.5 centimeters. I am then going to multiply that 2.5 times 3, get 7.5, and put a dot at 7.5. I'm then going to continue to do that with every point. So I'm going to draw a line from P to my next point. I'm going to measure from P to the coordinates of that point. It's about 1.5 centimeters. If you take 1.5 and multiply it by 3, you get 4.5. And I'll put a dot along that line at 4.5. And then my last example, I'm going to draw a line from P to my third one. I'm going to measure that distance. It is 2. 2 times 3 is 6. So along that line, I'm going to put a dot at 6. And once I have done those things, I am then going to connect my 3 dots. And that will be the image of my new figure. And if you take a look, it looks like my new triangle is about 3 times the size of my old one. When the scale factor is positive, the dilation goes away, like towards the figure. So if it's positive, the dilation will be this way. If it's negative, the dilation would come back the opposite way, on the other side of the center. For example, in our next one, we have S of -1/2. The 1/2 means it's going to get smaller, and the negative means that it's going to be on the other side of the center. So my new figure will be over here. So if you take a look, the first thing I'm going to do is I'm going to connect a point to P, but I'm then going to extend my line the other direction. I'm going to measure that distance. It is about 3 centimeters. Half of 3 is about 1.5. I'm then going to measure 1.5 the other direction and put my new point. So as you can tell, this distance is half of this, and it's on the other side of the center from my original figure. My next thing I'm going to do is I'm going to continue and I'm going to draw the line through P, again with a new point. I'm going to measure the distance. So in this case, my distance from that point to P is about 1.2 centimeters. Half of that is about 0.6. So then I'm going to measure about 0.6 away. Oh no, it's not 1.2, it's about 0.6, I'm sorry. So about half of 0.6 is about 0.3. So I'm going to measure about 0.3 there and put my dot, and that will be the new coordinates of that point. And then I'll do the same thing for my last example. Draw a line through P. That distance appears to be about 1.1. Half of 1.1 is about 0.55. I'm going to find that distance, put a dot, and then going to connect my 3 dots, and I will get my new image. And that new image should be half the size on the other side of the point, or the center. If you flip your page, the next thing we're going to do is we're going to give the coordinates of the center of the dilation for each figure. So what we're going to do here to get the center is what we're going to do is we're going to connect corresponding points. So in this first situation, if you connect A to A prime and draw a line, if you connect B to B prime and draw a line, and if you connect C to C prime and draw a line, they should all cross at the same point. And where they cross is called your center. So in this case, it looks like our center will be approximately 0, 0. On our next example, I'm going to connect N to N prime. I'm going to connect M to M prime, Q to Q prime, and if you connect P to P prime, they will all cross at the same point. And again, the point where they cross is your center. So in this case, our center will also be 0, 0. It is not always 0, 0. These are just 2 examples of where it would be. In our next example, we're going to try and find a scale factor of 2.5 from triangle ABC to DEF. The first thing you notice, if you have a scale factor of 2.5, you know that from ABC to DEF it's getting bigger. Because this is getting smaller, there's no way C could be your answer. Because this is getting bigger and this is getting bigger, these are your 2 possibilities. So then what you have to do is match corresponding points. We know that A matches D. So on this one and this one, we can clearly see that A and D are not matching. So that one's out. So then we'll check this one. A matches D, B matches E, and C matches F. So that will be our answer. In our next example, we are now having a scale factor of 0.4, which means our triangle should be getting smaller. So if you take ABC to DEF, we should have ABC being the bigger picture and DEF being the smaller picture. So in this case, ABC is bigger, getting smaller. This does not have that. This one's getting bigger, so that's wrong. This one's getting bigger, so that's wrong. So our answer must be A, and then we must match points. A matches D, B matches E, and C matches F, just like it says in the triangles. In our next situation, we're actually going to get the scale factors. The way you get the scale factors is the same way as we get similarity ratios. What you do is you just take and divide the 2 sides. The one thing you have to be careful of is if we are doing an expansion, we know that our ratio must be greater than 1. So, if you divide 4 by 10, or 10 by 4, one of those will give you a ratio or a scale factor that is bigger than 1. 4 divided by 10 is 0.4, but 10 divided by 4 is 2.5. So in this situation, our scale factor will be 2.5. In our next one, we're going to do the same thing. You could get a scale factor of 7 over 3 or 3 over 7. Because it's an expansion and it's getting bigger, we know that our similarity ratio, which is the same as our scale factor, must be getting bigger. So 3 over 7 is not getting bigger, so 7 divided by 3 is, so your scale factor there would be 2.3 repeating, or you could also actually just leave it as 7 over 3. On the other hand, if it's a contraction, that means it's getting smaller, so we need a number less than 1. So in this case, we could divide 5 by 2 or 2 by 5. If you divide 5 by 2, you get 2.5. There's no way that could be a contraction. So your contraction here would be 2/5, or you could actually write that as 0.4. Our next one is 4 and 12. So we could either have 4 over 12 or 12 over 4. Because 12 over 4 is 3, that would not get you a contraction. So we could have 4/12 as our contraction. If you reduce that, that's 1/3, or you could also write it as a decimal of 0.3 repeating. If you flip your page, the last example we're going to do is we are going to actually do some scale factors on coordinate planes. First one, draw the image of the figure with the given vertices under a dilation with a scale factor centered at the origin. List the new points. First thing we're going to do is I'm going to list my original points. Point M, it has the coordinates -2, 1. Point P has the coordinates -1, -1. And point N has the coordinates 2, 2. So if our scale factor is 3, what we are going to do to get our new coordinates is we are just going to take our original coordinates and multiply them. So in this case, if you take -2 times 3, you get -6. 1 times 3 is 3, and that will be the new coordinates of M. We will call M prime. If you do the same thing for P, -1 times 3 is -3. -1 times 3 is -3, and those will be our new coordinates for P prime. And if you do the same thing for N, 2 times 3 is 6, 2 times 3 is 6, and we have our new coordinates. If you are then going to graph them, this will be off our graph just a little bit, but if you go -6, 3, that'll be approximately up here. -3, -3. So we have M prime, P prime, and we will then have N prime. And again, it's off the page a little bit, but if you can kind of see, that will be our new figure, about 3 times the size. If you take a look at our next example, this time we're doing a scale factor of 1/2. So the first thing I'm going to do is I'm going to list the coordinates of A, B, and C. A has coordinates 2, 1. B has coordinates 4, 1. And C has coordinates 1, 4. To get our new points, what we're going to do is we're going to take our original points and multiply each part by 1/2. So half of 2 is 1. Half of 1 is 0.5. Half of 4 is 1. Half of 4 is 2. Half of 1 is 0.5. Half of 1 is 0.5. And half of 4 is 2. Once you have your new points, we can graph them. 1 is at 0.5. That's A prime. 2, 0.5. That'll be B prime. And C prime would be 0.52. And if you connect your new figure, it should be the same shape, but about half the size. In the last couple examples, we are now going to find scale factors and coordinates of new images. If you take a look at these two similar triangles, you have this first triangle right here, and you have the second triangle right here. The coordinates of the triangles are given. We are going to try and find D and then find the scale factor. The first thing I'm going to do is find the distances. From here to here, that distance will be 2, and from here to here, that distance will be 3. From the origin to point C, that distance is 4, and from the origin to point D, I'm going to call that distance X because we don't know what that is. If we then take and set up similar triangles, I'm going to say 2 corresponds to 4, and then I'm going to say 3 corresponds to X. So this side of the small triangle over the side of the big triangle equals the side of the small triangle over the side of the big triangle. If you cross multiply, you'll get 12 equals 2x. X will be 6. So once we have that, we know the coordinates. If this distance is 6, the coordinates of D will be 6, 0. Once we have the coordinates of D, you can then also list the scale factor. And the way you get the scale factor is you just take the ratio of a side length of one triangle to the side length of the other. Because we started with AOB, that distance was 2. The distance of COD in that same corresponding part there is 4. So our scale factor will be 1/2. So we have our coordinate and our scale factor. Let's take a look at the next one. It says, given that these two triangles are similar, the coordinates of P are -15, 0. The coordinates of M are -10, 0. And the coordinates of Q are 0, -30. We want to find the coordinates of N. All right, the first thing I'm going to do is I'm going to kind of redraw my triangles so it's a little bit bigger. Here's my first one. And here's my second one. Okay, so if this is O, M, and N, then this will be O, P, and N. From O to M it was 10. From O to P it was 15. From O to N we don't know. I'm going to call that Y because it's along my Y axis this time. And from O to Q it was 30. So from this situation we are going to first set up a proportion. 10 over 15 equals Y over 30. If you cross multiply, 15Y equals 300. Divide by 15. Y is going to be 20. So then the coordinates of this point right here, over here, oh, sorry, this was O. The coordinates of N over here, Q, excuse me. The coordinates of N over here is going to be, if this distance was 20, this coordinate right here would be 0, -20. The reason it's 0 on your X is because this time the coordinate is along your Y. We know that because it's on the Y axis, your X will be 0. And your Y is negative because it's below the origin. So 0, -20. And then you take and get your scale factor. 10 over 15 reduced is 2 over 3. So you have a scale factor and you have a coordinate. In our last example, we're going to do the same thing. We are going to find between the two similar triangles the coordinate of F and the scale factor. From here to here it was 4. From here to here it was 8. We do not know the coordinate here. I'm going to call that Y because it's along my Y axis. And along this distance is 6. We are then going to set up proportions. So the first thing I'm going to do is pick a side on my small triangle. I'm going to pick 4. 4 corresponds to 8. And go back to my original triangle. Y corresponds to 6. When you cross multiply, 8Y equals 24. When you divide by 8, Y is going to be 3. So the coordinates of F in this case, because that distance is 3, the coordinates of F will be 0, 3. Once you have that, you then need to get the scale factor. So if you take the side length of your small triangle, put it over the side length of your big one, your scale factor reduced will then be 1/2. So we have your new coordinate F and your scale factor.